Hi friends, let us try to understand what recursion is. Okay, let's see the definition in Wikipedia. It says recursion in computer science is a method of solving problem where solution depends on solution to smaller instances of the same problem. I believe which is a bit difficult to understand if you really don't know what recursion is and try to understand it for the first time. Okay, to put it in simple terms, a recursion is a function call to itself. It means there is a function, and inside the function there is a call to the same function. First of all, let's see how this can be achieved and what are the consequences if we do that one. Yeah. So let me write a very small program, small function, and I'll call it as recursive function. Like function. Okay. Let me say print. I'll say go corona. Let me call this function. I'm doing control shift enter. This function has given call to this and it just printed corona. What happens if I call corona inside corona? Yeah, recursive function. So this call has given here, it printed go corona. This is called this function which is called corona. This function which is called this function prints corona and keeps on printing. And at certain point in time it says maximum recursion depth exceeded while calling a Python object. It means there is a limit to which you can call functions recursively. After that, it's a stack overflow. Yeah. So we don't know what's happening, who is calling whom. So just to make it more clear, I'm trying to pass an integer and just try to print that integer. Okay. Let me print that one here. And when I call it for the next time, I just increase it by 1. Let's see what happens. See, the first one is 0, which has come here and which is printed, and then the same function is called with 1 is printed, the same function is called with 2 is printed, 2 has called for 3 has called for 4, etc. And again, the only difference from previous to this is just an extra number. Yeah, we have had enough. So 2953. Yeah, there is a limit. We are not discussing about the limits here. Okay. But in my view, this is still not a way to understand recursion. You might have all seen a recursion program for calculating factorial, but somehow they tell you how to calculate. That's fine. That's how the recursion works. But to understand recursion, let's dig little bit deeper and try to see. What I'm not going to do is to just put an end to this. I don't want to go recursively infinitely or just crash it at certain point in time. I say, okay, do this as long as the count is less than 3. Okay, if count is less than 3, only then do this. Let's see what happens. Oh, excellent. 0 has given come here and 0 is printed, and then 1 is less than 3, 1 is printed, 2 is less than 3 printed, 3 is not less than 3 came out. Okay, again in my view this is not sufficient. Let me add 2 more statements to make it more clear, and then I will try to illustrate this with a with Excel sheet, function calls and returns and etc. Okay, print, I'll say enter count. This is an entry point, this is exit. Okay, let me try to run. So now this tells you with what I entered, again with what I called the next function, with what I entered, with what I exited. Let me try to put this in an Excel sheet, the whole stuff in an Excel sheet, and try to take you through the outputs, okay, of the recursion. I already did that. I'll share with you. That looks like this. So here in this function I have 1 2 3 4 5 statements, of which there is a condition, and these two are executed only if this condition is true. So the same stuff I put here, and the coloring just tells you that if the statement executed, I'll just do it by green. If it's the current one, then yellow. Pending is this brown, and skipped is black. If you don't understand this currently, don't worry, let me try to take you this. Assuming I'm calling it with 0, this is the main call, so I started the call. All others supposed to be executed, they are still pending, so the function call is given here. It prints the enter count, because started with 0, count is 0. The print statement is enter count. Why I'm putting so far is you will come to know 0. So this is printed. Sorry, I'll make it green. Okay. Count is smaller than 3. 0, yes, 0 is smaller than 3. I'll also write what is the count here. Okay. 3, yes. And then it says print go corona count. So it says go corona, it's printed, and the count is 0. Now recursive function, the same function is called with 0 plus 1, which is 1. It means I want all these 4 again. I should not have removed the color. This is the second call starting from here. With count as 1, which is not here, which should be next. So anything happens after that in the main call is here. Okay. So the next function is called with recursive function 1. So this is the current function. So we called it with 1. Yes. Now the count is 1. So print enter count. I'll print 1 here. So this is done. Whatever is done, I'm just putting a green color. Is the count I just take this 2 down. Is the count is less than 3? Yes, it's less than 3. So I say print corona 1. Fine. So this also is printed. Let's make it green. Excellent. Now the function is called with 2. So this is the function call. This is the current function call. Guys, remember, this is still pending for the main call. This is still pending for the second call. Now there is a third call. Everything should be red. Nothing is executed. This is the call, so I just make it yellow. The call is given with 1 plus 1, which is 2. 2. It prints corona with 2. So this is done. Count is less than, yes, 2 is less than 3. So I'm printing again corona with 2. Sorry, I'm again let me make it green. This is important. It's you need to have patience. So now this is called with 3. Insert columns to left. Insert columns to left. Insert columns to left. I'll just take this one out. Delete. I'll just pause before I make some no need to pause. One more. So the same thing is called so this means this is executed after this, still pending. The main one is still pending. It's not done. Exactly. Now this call, and this is called with 3. Count is now 3. So let me put everything in green again. Okay, that's excellent. Not here, my mistake. It should be here. So it means this will be printed after this. This will be printed after this. This will be printed after this. Excellent. Now, since we entered with 3, I'll have to just print 3. This is done. Is count less than 3? Is 3 less than 3? No. Then I'm not going to do this. So these two are not calculated, and then finally this gets printed. Print exit count with 3. Exit count with 3. So this function is done. The last function where the recursion ends is done. So this is done. It means this is done. It means this is done. Now I'll have to print this. This is called for 2. So count is 2. So exit count for 2. I'm going to green this one. If 2 is ending, it means this is ending. This means this is ending. This means now only thing is this now, okay? And there is one more for 0. So 1. So I'm going to color it with green. Finally, the main call with 0. So if this is ending, so this is ending, this is ending, this is ending. Everything is done. So this, we started with 0, so we end with 0. Now this exactly resembles my output here. Let me just take and print it here. Yes, whatever. Sorry, man. Copy, paste. I don't care now. Oh, its output is not printed, whatever. So does this make sense now? How to call function to a function, and then when it exits, it goes back to the next statement of the same function. So that's what we're doing here. When this exited here, so it means this exited, then this is the next statement of its previous call. If this is good enough explanation for you guys, please let me know in the comment section. I have one more wonderful example using recursion, which I will share soon. Okay, thanks, bye.